Good morning, everyone. All right, we are so excited to see you this morning. Thank you for being here. I know it's been a really long week at Ignite, and I'm sure you've heard a lot of new information. So really grateful to have you here with us this morning. My name is Stefanie Lemon. I'm the product lead for the VM team in General Compute. This is Varun Shandilya, and he leads the product team for VMSS, Spot, Compute Fleet, and more. So I know you've learned a lot this week, but we are going to have an information-packed session for you with lots of demos, so it'll be pretty quick as we go through all the content. But the available content will be online after, and you can use that as a reference if needed. All right, so let's get going. So for our agenda for today, I'll start by covering what's new when it comes to VM selection and the new features. Then we'll talk about some of the exciting innovations in infrastructure security. And lastly, Varun will cover the scale section, which will help you deploy VMs faster and with more resiliency. All right. So first, we'll talk about the portfolio. As you probably know, Azure has a broad selection of VMs to suit a wide range of workloads. In this session, we'll focus on the general purpose, compute-intensive, memory-optimized, and confidential computing VMs. Each of these families have several new additions that have been recently made generally available or are in preview now. First, let's talk about the general availability of our in-house designed Cobalt 100 ARM-based VMs. These VMs are available in multiple regions across North America, EMEA, and Asia, with more regions to be announced in the coming months. They have 50% better price performance and 40% better performance than our previous generation ARM VMs. We see even better performance gains for Java applications, web servers, and .NET applications. And you'll see a huge increase in the local disk performance and throughput thanks to NVMe support. And by the way, you'll see QR codes throughout this session, and you can get more details about each of the announcements through those codes. Taking a quick look at the Cobalt 100 VM specifications in more detail. As you can see, we have three families. The DPL, which is a lower memory family that is ideal for media encoding, gaming servers, and small databases and microservices. There's a mid-memory VM series called DP, which works well for most application and web servers and small to medium databases. And finally, there's a memory-optimized series starting with EP, which are best suited for large databases, in-memory caches, and data analytics workloads. And all three memory configurations are available with and without local storage options, so you can find the right fit for your performance and budget needs. All right, and we're going to show we've got a number of customers already testing these VMs and using them. Some of them have observed up to 40% performance improvement for their workloads. And we expect to see many more customers using these VMs in the coming months. So we're really excited to hear about what customers are seeing from a benefit standpoint. Next, I'd like to go through, we're going to show a quick video. This is from one of our customers, David Meyer. He's the Senior Vice President of Products from Databricks. He wasn't able to be here today, but he did create this video. And it's going to show you what the benefits that he's seen with Cobalt.
Hi, everybody. Thank you so much for giving me a few minutes. My name is David Meyer from Databricks. We're going to talk about how Azure Databricks gets the benefit of Cobalt 100 VMs. So there's three things: the performance improvements we get, how it's possible because of our engine, and how the first-party service of Azure Databricks plugs into everything you need for data and AI at scale. So the data intelligence platform of Azure Databricks, it's based on this thing called the Lakehouse, where you put all of your data in ADLS V2, in Delta, Iceberg, Hudi, or any Parquet columnar format if it's structured. And a Unity catalog lets you govern that and secure it once. You never have to copy that data. And that security governance works across all data and AI workload types, from ingest, ETL, streaming, data warehousing, all the way to AI. And this is is the platform that's been so successful across verticals and regions because it's powerful. We spin up tens of millions of machines a day in the system. We'll spin up 1 billion machines between now and the end of the year. That's scale. Now, with massive engineering investment, we've taken this whole engine, we've rewritten it in C++ in a vectorized engine that can take astounding leverage of these Cobalt 100 VMs. So vectorized execution, what is it? Instead of processing each row of data in the Spark JVM, in typical Spark processes, it's all in C++ and using compute kernels to process vectors of data. A vector is many rows at a time on a simple operation. It radically speeds this up, okay? And it's cache and CPU friendly, and so it can really, really go to town on these Cobalt VMs. In fact, if you take a typical non-SMD processor and process this, and then move it to a SIMD processor, this is billions of rows processed per core per second, and what we're able to do with these new Cobalt 100 VMs. It's astounding, and the throughput brings you up to 30% efficiency gains and speed gains across all of your data and AI workloads, and at scale, that's huge. Now, this is deeply integrated with the core of Azure, right? It's built on top of ADLS, it's integrated with Azure AD, and it publishes directly to Power BI, brings in stuff from Azure Event Hubs, is visible inside Purview. So it's baked into everything you use for this incredible scale, and it takes full advantage of the massive performance and efficiency gains of Cobalt 100 VMs because of its architecture, and who wins? You win. So please scan this QR code, try this today, Azure Databricks, pick the Cobalt VMs, it's live, it's available today, and do data and AI like never before. Thank you.
All right. Great. Glad we got that working. Thanks for your patience. So the next announcement I'd like to make is that our AMD-based VMs, the general purpose and memory optimized and compute optimized V6 version has generally available as of yesterday. So I'm super excited to make that announcement. We are really excited. This is going to be available in several regions. And I just wanted to point out in the FA series, it's going to be unique that these are SMT disabled. So they'll be well suited for applications that need high single-threaded CPU performance. And compared to all of our previous AMD VMs, there are significant improvements in CPU performance, networking bandwidth, and local storage performance. Next, I'd like to just bring to your attention, if you haven't heard about FXV2, this is a new compute-optimized VM series. This is 2nd gen, powered by the 5th generation Intel Xeon processor. These VMs have high memory, so they're ideal for SQL, other databases, data analytics, and some EDA workloads, or really any workload that needs a large amount of memory, higher performance, and significant I/O bandwidth than the E series offers today. So these VMs are going to have up to 50% faster CPU performance than the prior generation, and significant improvements across the board. So we also have Azure Boost, which helps with the remote storage performance and networking compared to the prior gen. And if you're interested, you can sign up for the preview. All right, next we'll talk about the technology that powers our VMs. So one of the most significant advancements in VM capabilities comes from Azure Boost. You may have heard about it. It was announced last year, and it's a key technology that offloads virtualization processes traditionally done by the host infrastructure. So that enables greater networking and storage performance. So we have a number of enhancements coming with remote storage throughput, local storage IOPS, and remote storage IOPS, all being industry leading. And we can also, with the next technology, deliver up to 400,000 network connections per second and 26 gigabytes per second of local storage throughput. And these capabilities will be available in VMs next year. And across our VM portfolio, Azure Boost continues to expand with millions of VMs running per day on Azure Boost. And all the new hardware is shipping with Azure Boost, including HPC and GPU SKUs to support the cutting-edge performance needed by AI and HPC workloads. All right, we're going to show a quick demo of some of these new improvements.
In this demo, I'll describe a few of the major improvements we've made to Azure Boost. First, I'm going to showcase a new technology that brings hardware offloading to network connection setup, a function previously done in software. With hardware network connection setup, we can provide an order of magnitude increase in connection setup rate, up to 400,000, all with significantly reduced connection setup latencies. I'm SSH'd into a pair of VMs with hardware connection setup enabled. To show the performance of this capability, I'll run a connection setup stress test. Almost immediately, you'll notice that I'm seeing over 400,000 connections per second. Even more impressive is the reduction in connection setup latencies down to around 400 microseconds, or just 0.4 milliseconds. This showcases the advantage of offloading SDN processing to hardware, coming soon to Azure Boost. Next, I have a general-purpose VM equipped with 24 NVMe interface-based Azure Premium v2 data disks, which offers industry-leading performance and ultra-low latency at a lower price. The first demo showcases IOPS using a 4 KB block size, where we achieve around 750,000 IOPS through Azure Boost's full offloading data plane to the underlying hardware. The second demo focuses on throughput with a 256 KB block size, demonstrating around 14 gigabytes per second bandwidth. With both high IOPS and throughput powered by Azure Boost, we're well equipped to support our customers' general-purpose workloads. Last, for local storage performance, I created a future storage-optimized Ubuntu VM attached to 12 of the latest Azure Boost SSDs. I'll use the FIO tool to measure performance. The workload runs for 2 minutes, and it can reach 6.6 million I/O per second. Now I'll jump to when the test finished, and here's the final result. I run a TPCC workload with 640 warehouses on local NVMe disks. It achieved 1.8 million transactions per minute at steady state. Now live migration starts, and as the local disk content is migrating, transactions per minute starts to decline slightly. Then blackout starts and finishes quickly. After blackout, TPCC transaction recovers and goes back to 1.8 million per minute, and live migration completes. Here is an overview of TPCC transactions before, during, and after live migration.
All right, so just showing you also, with live migration, you get the added resiliency in case there's any reason why the VM needs to move from one host to another. All right, and the last topic in this section is about how to find the right VM for your workload. As you probably heard at Ignite, we've a lot about Copilot. So naturally, we're working on ways to integrate Copilot into the Azure experience. Given the breadth of the Azure VM portfolio and the wide range of sizes, sometimes it can be difficult to determine which size is the right one for your workload. So now, Azure Portal users can use Copilot to help you find the best VM. And this should streamline your infrastructure deployment decisions and may also help save cost. So we have a quick demo to show you Copilot in action.
I'm excited to show you how Microsoft Copilot in Azure can help you choose the best virtual machine size for your workload. Azure has hundreds of VM size offerings to serve a variety of workloads, from complex machine learning tasks to running web servers. Picking the right size for your workload based on capacity, quota, and workload needs can be challenging, and we hope Copilot can help. How about an example? Say we want to set up a virtual machine that can run Selenium UI tests against our website. We have hundreds of tests, and we run them periodically throughout the day. Anywhere in the Azure portal, I can engage Copilot to help provide a size recommendation for my scenario. As you can see, Copilot follows up with related questions that are specific to the workload that I suggested. In this case, Copilot asks me about how many tests I want to run and the computational intensiveness of each test. No matter what workload description I provide, Copilot knows to ask directed questions that help it make the best recommendation. The more information I'm able to share with Copilot, the better recommendation it's able to give me. In this case, I want to run 500 tests a day using the Selenium framework, and I also note that the tests can be run in parallel. As you can see, Copilot is able to recommend a specific set of sizes with a CPU and RAM configuration that makes sense for my workload. Because Copilot is tightly integrated with my Azure environment, it knows to provide recommendations that I have a quota and capacity for. In case my requirements align with a size I don't have a quota for, Copilot can help direct me to request more quota for that size. This makes it much easier to select from our vast variety of VM sizes and get started immediately with deploying new workloads.
All right, great. So next we'll go into security and talk about the innovations there. Going back to Azure Boost, it also plays a key role in increasing security. It enforces the hardware attestation, which decreases the surface of attack by allowing only trusted machines to run in the production environment. So it uses cryptography to ensure that the hardware and firmware hasn't been tampered with and prevents any untrusted machines from going into production. So the attestation enables protection from malicious firmware, pre-boot malware, rootkits, compromised OS images, and misconfigurations. So we also have a demo to show you how the attestation works.
In this demo, I'll show Azure Boost passing and failing attestation. This demo takes place in a development environment, since production machines have security controls in place preventing this type of access. The first device I'm using is in full compliance with our attestation policies and will successfully pass attestation. You can see that the machine already has a trusted identity certificate. Next, I'll remove the trusted identity certificate and verify it has been removed. After verifying its removal, I'll explicitly trigger attestation of the device. Upon completion of the attestation request, I can verify that a trusted identity certificate has been received by the device. Then I can check the attestation client logs and see that the trusted identity was successfully provisioned to the machine. The second device can boot any type of operating system, which is a violation of our attestation policy and will result in it failing attestation. You can see that it currently does not have a trusted identity certificate. I'll trigger attestation, and you can see that the attestation client encountered an error. Checking the attestation client log, notice that this device encountered an attestation enforcement failure, meaning that it is not compliant with our attestation policies. Also notice that no trusted identity certificate is present on the device due to it failing attestation. This failure scenario demonstrated only a single policy failure. I configured no other policies to fail. Every attestation request for Azure Boost has all our attestation policies applied, ranging from ensuring secure boot is enabled, the operating system image is signed by an explicitly trusted root, the built-in keys are explicitly trusted, integrity validation of the firmware, no debuggers are connected, code integrity, security-enhanced Linux is enabled, and so on.
All right. Okay, and you may have heard this week we also announced the preview of Azure Confidential Clean Rooms. So this enables multi-party collaboration in a secure manner. So organizations, whether they're within the same company or across outside companies, you can control the use of the data and make sure that it's only used for the purpose that it's intended. And you can use it for data analytics or sharing of data for AI model development and inferencing. And this capability is built on the confidential computing hardware and principles of verifiable trust. So let's see an example of how an organization can use the confidential clean rooms in this demo.
Fabricam, a furniture store chain, wants to collaborate with Contoso, a data analytics firm, to create a targeted advertising campaign. Both collaborators are concerned about sharing their private data. Confidential clean rooms can make this possible with privacy-enhanced data collaboration. First, Fabricam sets up a collaboration and invites Contoso to it. Then, Fabricam proposes a tamper-proof contract that contains the constraints, like application workload, encryption settings, and storage-related details of each data source. Plus, details about where the encrypted output insights from the clean room will be received. Now that the contract and queries are proposed, both collaborators agree on them, upload their respective keys with the key release policy to their key vaults, and deploy the clean room to generate insights. They can also obtain a tamper-proof trail of events for audit purposes. To show the clean room in action, we already have a clean room configured, and we are going to run an approved query that matches users from both collaborators to generate target audience. Fabricam has a query approved by Contoso with document ID 101. You can see that the query is in the accepted state. Fabricam makes a call to run the query in the clean room, and you can see that the query is run successfully, and the output is encrypted and stored as a CSV file in blob storage, which Fabricam alone can decrypt. Fabricam then downloads and decrypts the encrypted output to their local computer. Now, Fabricam got the IDs for campaign targeting without accessing private data of Contoso. Fabricam has another query with document ID 103, which is not approved by Contoso, as it's trying to access private information from Contoso. When Fabricam tries to run this query, it errors out with the message that it has not been approved by all collaborators.
All right. Okay. So this last part, I will cover 2 recent announcements on confidential computing VMs. So this week, we announced the preview of the confidential VMs based on the AMD 4th Gen EPYC processor. And they come in the general purpose DCA and the memory optimized ECA series. And these VMs protect data in memory by supporting a VM-wide, hardware-based, and attestable trusted execution environment. And so these guest attestation libraries let users ensure that the sensitive data is not processed on the VM until the underlying hardware and the software in the VM are verified. So customers can use these VMs without any code changes. And compared to our prior generations, there's a number of benefits here using the Windows virtualization-based security, up to 25% more performance with Windows Server, and this will be our widest available confidential VM to date. And the second VM announcement was around the Azure Confidential GPUs. So we're bringing GPU-level performance to confidential computing for the first time, and we recently announced GA with the NVIDIA H100 Tensor Core GPUs. So with confidential computing guarantees, the hypervisor is blocked from accessing confidential VM system memory and blocked from reading GPU memory. So with the NVIDIA GPU driver operating inside the confidential VM, we are able to encrypt all transfers across the PCIe bus, and thus we're protected against any physical attacks through that interface. So that's all for the major recent announcements in infrastructure security. Now I'll hand it over to Varun.
Thank you, Stephanie. Good morning, all. So next what we're going to cover is scale. With all the awesome new hardware and VMs that are coming out, we also understand scale is very important because you want to deploy these VMs at scale, and that's what we're going to discuss next. The first topic that I'm going to get into is how can we accelerate the deployments. This year at Build, we announced a preview of a product named Azure Compute Fleet. This product lets you deploy thousands of VMs at scale using a variety of different SKUs, and you can choose any of the latest SKUs that Stephanie just talked about or the SKUs that you have. And we will do the hard work of finding the capacity in the region given the SKUs that you have given us. I'm happy to announce that we're expanding the preview to all public regions of Azure. And we're so excited about this product, we've been adding more functionality to it. We understand a lot of customers have their deployments in multiple regions, and there's a lot of workloads who might not have data residency requirements or data in one place, and you can have deployments in multiple regions. You can find compute in multiple regions. To simplify that, I'm happy to announce a preview of a new feature, and it's industry-first feature of multi-region deployments. What you can do is you can tell Azure Fleet up to 3 regions where you want to deploy, and then the SKUs that you want to use, and we will do the heavy lifting of finding the capacity in the right region or set of right regions for you to get the capacity that you need. Let's look at that in a demo.
In this demo, I'll demonstrate multi-region compute fleet using a single API to run your workload in more than one region. I'll deploy this by using ARM template deployment. The location here corresponds to where the compute fleet resource will be created. I'm requesting 5 spot and 5 on-demand VMs. The allocation strategy used for spot VMs is capacity optimized, and for on-demand VMs is lowest price. In the VM sizes profile, I can specify up to 15 VM sizes. I'm setting 2 additional locations here that can be used to run the VMs. In the template file, I'm setting these parameters along with a base virtual machine profile and any overrides for additional locations that I specified. Now I'll deploy the ARM template using the Azure command line interface. The VM size and region will be chosen based on the allocation strategies provided. And now you see the compute fleet resource on the portal. The location is North Europe, and there are 5 on-demand VMs and 5 spot VMs. Over on the Instances tab, you can see all these VMs. The VM size selected for spot is standard D16 ASV5 in the North Europe region, and for on-demand VMs, it's standard D16 LDSV5 in the West US region.
Awesome. So as you can see, we are able to deploy multiple price points of VMs, saving you cost across different regions as well. So that gives you the ability to find the capacity at the right price in the right region and get successful with the workloads that you run. And we didn't even just stop there. So as we talked about, up to 15 SKUs, and we understand sometimes choosing the right SKU becomes very complex. And which SKU should I choose? What do I need to do to get the right capacity? To simplify that, we've been hearing a lot from customers that customers are okay defining their minimum requirements of what compute do they need. And to enable that, we have attribute-based VM selection. Using this, you can specify the minimum requirements that you have, which is what amount of CPU do you need, 4 cores or 8 cores, 12, 32, memory, IOPS. Those are minimum requirements that you tell us, and based on that, we do the heavy lifting of finding the right SKU for your deployment. And it also enables you to future-safe your deployments as new VMs get released. As they meet your minimum requirements, we'll keep deploying those for you. So you don't have to change your CI/CD pipelines for new SKUs that are coming in. Let's look at this in a quick demo.
In this video, I'll demo Compute Fleet with VM attributes using ARM template deployment. In my parameters file, I'm requesting 5 spot VMs with capacity-optimized allocation strategy, plus 5 on-demand VMs with lowest price allocation strategy. Now, instead of specifying the VM sizes, I'm specifying VM attributes. Virtual CPU count is a required attribute specifying the minimum and maximum number of virtual CPUs for a VM size. Memory in GB is also required, and it indicates the minimum and maximum memory in GB for a VM size. All other attributes are optional. Memory in GB per virtual CPU refers to the ratio of memory to virtual CPU. VM categories is a list of Azure VM categories that a VM size should belong to. Some of the other optional attributes include CPU manufacturers, architecture types, network bandwidth in MVPS, accelerator support, local storage support, allowed VM sizes, excluded VM sizes, and so on. In the template file, I'm setting these parameters under VM attributes property. Next, I'll deploy the ARM template using the Azure command line interface. Azure will choose the VM sizes based on the VM attributes and allocation strategy. Now you can see the Compute Fleet resource on the portal has 5 spot and 5 regular VMs. On the Instances tab, you can see 2 VM sizes, standard D8S v3 and standard D8A v4 for both spot and on-demand VMs. This demonstrates the flexibility of VM sizes using VM attributes in Compute Fleet.
Next, as we keep talking about Spot, it's a great way of saving money. And if folks who don't know Spot, Spot is our VM price point where we give you unused capacity of compute for up to 90% discount. In exchange for that, we can evict those VMs when we need capacity. And we've heard a lot from customers that they want to feel confident and fail fast before they deploy their Spot VMs. To help with that and build more confidence, we are introducing in preview Spot Placement Score, using which you can define the SKU, the region, and the quantity that you need, and we'll give you a recommendation of high, medium, or low, and that should give you a signal that you are good to deploy, and you're going to get the Spot capacity that you're looking for. Or if it's medium or low, you can make a choice of changing the SKU to something else so that you can find that capacity. Next, we also understand that when you deploy your infrastructure, when you deploy your workloads, there are two aspects to it. One is to get the raw compute capacity, the VMs, and the other one is you have to do setup and initialization of your application on that. And sometimes the setup takes a lot of time. And when you need the VM to be available for you to serve the workload needs that you have, it can take a long amount of time. And to shorten that, we are announcing a GA for standby pools, which lets you configure these VMs ahead of time, put them in your pool, and when you scale out, we will automatically pull VMs out of that and deploy it. As you can see in this diagram, you can create VMs which are either running, where you are very latency sensitive, you want VMs in less than a second, right? And the other one is, if you want to save cost, you can configure them and you can keep them in a deallocated state. So you're not paying for compute capacity, but your VMs are pre-configured and ready, and then when you ask for new VMs, we will start those VMs and they will be available for you. And we just didn't stop there. We also understand for customers who are using containers, Azure Container Instances, there the latency is a prime use case that you need your containers to be available at the moment. So we are also introducing a preview of standby pools in Azure Container Instances, which can help you get a container or hundreds of containers or thousands of containers in less than a second when you need them. Next topic that I want to cover is resiliency, which is very important in cloud, that you want your workload to be resilient, and what can we help with. The first aspect that I want to talk about is how are we helping you to be more zonal resilient. The first one, which a lot of customers in Azure who've been deploying for a long period of time have deployed their VMs as regional VMs, and we want to help customers to migrate to a zonal VM. So using the conversion of regional to zonal VM, we are able to convert your VM from a regional resource, including all the storage and IP and networking and whatnot, to become to a zonal. That's generally available as of now. We also know if you're in a zonal setting and if you have VMs in two different zones, and if one zone goes down, you want that data or the disk to be detached and attached to the new zone so that your workload doesn't suffer any outages. Now with zonal failure and recovery for ZRS disk, you can detach the disk and you can attach it to the new zone or the zone which is available for you to be highly resilient in that case. Similarly, for VMSS customers, which is Virtual Machine Scale Set product, who've deployed their VMSS as a regional, we are also offering a GA where you can expand your VMSS from regional to zonal. And what you do is you do an update operation on VMSS. You add the zones that you want to in that region, and all the new scale outs that will happen in the zonal setting, or the new VMs will kind of come in the zones that you've specified. And VMSS is smart in that way. When you scale them in, we will first scale in the regional VMs before we touch the zonal VMs. And that's how you can, without any downtime, migrate your workloads to be more resilient with zonal settings rather than in a regional setting, and you don't have to have any downtime with it. The last aspect on the zonal resiliency and on the resiliency is about failures that happen during two very critical times of a VM. One is the create and one is the delete. And we are happy to announce a preview where we are gonna we're gonna recover from failures of create and delete as they're happening, so you don't have to go back and look at those failures and recreate your VMs or do a delete operation. I'm short on time, so I'm gonna skip this demo.
In this video,
Sorry. The last aspect that I want to kind of bring in is around virtual machine skill sets and the enhancements that we are doing. We've heard a lot from customers that having more control on their scale sets is very important. We also understand that you want to have high availability as upgrades come through. And we recommend that customers have upgrades available for their scale sets because it keeps you safe. You apply all your security updates as that, and you go from an older generation of a VM to a newer generation of a VM. You get better price performance for those. For that, we are happy to announce the upgrade policies on virtual machine scale set flexible orchestration mode as of today. The next aspect I want to kind of spend a little bit of time on is max surge. And this technology helps you to have 100% availability as you go through the upgrades. In this, what we do is we add extra capacity to your scale set so that the upgrades do not impact your availability of your workload. And that is also available as GA as of now. And the last one, to give you more control, we're also enabling custom metrics for your rolling upgrades, in which you can specify in which order your upgrades should happen rather than us choosing the order in which the upgrades happen. You have more control, you can specify. You can also specify which VMs to skip in case there is something happening with those VMs or like they're serving traffic. You can tell us that we should skip these VMs from upgrades and we will not touch them. So you have more control, and it's integrated with rolling upgrades, application health, OS upgrades, and all the upgrades that we do within scale sets. To wrap up, we are committed to provide you more selection for VMs so that you are getting the best price performance, the best capabilities from Azure using Cobalt 100, Azure Boost capabilities that Stefanie just talked about. Security is a prime focus for us, and that's where you're seeing a lot of innovation in confidential VMs, Azure Boost, confidential clean rooms, and attestation that Stefanie just talked about. And lastly, we understand scale is very important. You don't want to just deploy one VM, you want two, you want to deploy thousands of VM and have a great operational experience. So that's where like Azure Compute Fleet, virtual machine scale set, and all the enhancements that we've been doing come into place. Here are some of the additional resources, all the blogs that offer all the announcements that we've just made. You can go to any of these links to learn more about them. These are some of the videos where Databricks and Snowflake have been talking about how are they using our services and how benefit that they are getting out of Azure. And lastly, we want to thank you to be here. I was very skeptical Friday morning, 9 a.m. after a party on Thursday, how many people show up. So we really thank you for being here. And we would really appreciate if you can scan the QR code and give us feedback on how we did, or any feedback that you have on compute. I have 1 minute 43 seconds for any questions that you might have. I know you will have a lot of questions. But me and Stefanie are going to be here, so if you want to chat afterwards, because they will kick us out like Oscars. But thank you so much.
Thank you very much.